52.
What? Why? This is an honors class. This is where you don't do that. Okay. How's everyone's midterms week going?
Failing them.
Great. Okay. Come on, this is an honors class. We need to see some more excitement about midterms. This is what we like doing.
I got like a 79.
Okay. Well, today we have two micro lessons. The first one is workflow. This is where you guys are going to learn how to tailor your developer environment to yourself. Say, for instance, you really like using the keyboard. Well, you're going to learn how to minimize the use of your mouse. And say you really like one particular language, you're going to learn how to tailor your entire developer environment, your entire computer, to make sure that that one language works faster and better than any other. You're going to learn about text editors, and you'll hopefully introduce the big flame war between Emacs and Vim. Beyond that, we have APIs by Eric. APIs are the cool black boxes that make the internet do magical things, or that that help you do magical things with your computers. These are what make hackathons possible, because they basically take a really, really, really difficult and non-trivial functionality and make it a single function call, or maybe a string of function calls. But the point is they make them really, really simple and let you do some really amazing things in some very easy ways. Also, a quick note about homework. We've noticed that a lot of you are having some difficulty with your homework, and that's not a problem. This is an honors class. You should expect homework to be hard. And because of that, we're going to extend the homework deadline by a week. Yeah.
It wasn't even hard. Yeah, there was like nothing. You just had to do asterisks until the end.
I found today's homework difficult. Guys, you said that. How many of you find this homework difficult? Okay, well, the half an hour that we normally have in class to let you guys work together, we're going to increase that to 40 minutes. And in that additional 10 minutes, we're going to have a homework workshop at the back. So if there's any difficulty you have, we can address that in class today in those 40 minutes. We're going to talk about the Connie, who has something really, really exciting to announce for you guys.
Hi guys, so I know a few of you have already been invited to the Google Scavenger Hunt. Like I think Front Row has, maybe a few others, but basically every year Google sponsors an event called the Scavenger Hunt, where you run around campus, you take a lot of cool pictures, like for example, you drink out of a fountain, you go and rub Lincoln's nose, actually you pick his nose, and then like you eat and everything's sponsored by Google. There's free food, there's free prizes, there's like a lot of like people walking around. It's just a really good place to meet people and kind of explore maybe some parts of campus you haven't seen yet. So last year, for example, there were things where you had to make gifts, there were things where you had to do funny things on the quad. Some people stole a frisbee and drank out of a fountain, so that's always fun. So if it sounds like something you might be interested in, like be sure to join the event on Facebook, or contact me or Ankit Jain to get more information. It's next week, October 5th at 5 p.m. right here, and we're going to have our opening ceremony here, and then you're going to go off and take your pictures, and then afterwards you're going to meet up at ECB. Okay? Thank you. So next we have Aravind and Shotaro giving a workflow demonstration. Let's go.
Hey guys, my name is Aravind. I'm sure you guys have all met me before. This is Shotaro, and today we're going to be talking about workflows. So what I mean by workflows is we mean like your development environment, basically what you use on a daily basis to develop. So we're going to show you a couple examples of like possible factors in a development environment, and hopefully you'll be able to see which one clicks with you best, and after this lecture, maybe define your own development environment.
Hey guys, so I'm Shotaro, as you heard, and today we're going over how to set up your efficient workflow. So what we mean by that is we want you to set up your own workflow when it comes to developing. So the first thing I'll go over is operating systems. This is what I call your forced upon best friend, because you can't really avoid not working with an OS when it comes to developing, at least. So there are a couple. The first thing we need to talk about when we talk about operating systems is the fact of your operating system choice. And the first operating system that we'll go over is Microsoft Windows 7, 8, all the Windowses. I'm pretty sure most of you guys are familiar with Windows. It's a very stable OS, obviously. They have good hardware support. They have good libraries. But the problem with Windows, if you've developed on it before, is that it's a huge pain to get a lot of things running. How many of you have tried to install like Python and pip together? Did you guys have fun doing that?
Yeah.
No, it's not fun doing that at all. So this is what I mean. It kind of hinders your development progress, and it has an apparent lack of customizability. But let's look at an OS that actually does allow you to have this customizability. This is Linux. Who actually uses Linux here? Either on a virtual machine, yeah? That's actually a good amount of people. If you haven't, this is what I recommend you to choose, because you have a lot of choices. Each individual Linux has like a different feel to it. Some base their UI design on Mac OS X. Other systems look at Windows when it comes to UI design. And it has very good package managing, which Aravind will be going over next. However, Linux does have a lack of hardware support. Its drivers, if you've ever bothered to install them, it's not fun to do at all. And especially with the introduction of Windows 10, and with doing something basically, it's a little difficult to install for laptops. So this is why we have a compromise, like any good choice, and that's Mac OS X. I can see most of you, and actually most of the core staff too, use Mac OS X. That's because come on guys, it's beautiful. Mac OS X looks awesome. It does have a lot of hardware support, and it's pretty customizable. However, just know that Mac OS X comes with very limited hardware choices. You can only choose between 2 or 3. You can't really make yourself a desktop of OS X unless you have a Hackintosh. And the fact that with the limited hardware choice, it's also very expensive. So guys, just use Linux. Just try it out. If you haven't already, try it out. A virtual machine is the easier way to go. But if you don't want to, you can use a USB bootable and load up Linux. And my personal favorite is a distribution called Linux Mint. I don't think you can see it. Just know that that is probably one of my most favorite ones. Now next, we're going to be going over package management.
So I want to quickly talk about package managers. And package managers basically are a great way to basically manage the software that's on your system. So the first thing I want to cover is what a package is. So a package in software is very similar to how a package is in real life. You have a box, and in the box, there are a couple tools that accomplish a single task. And on top of that box, there's a label that tells you exactly what it does and what's inside. So packages in computer software are a collection of tools or software or scripts or some functionality that accomplishes a single task. And the reason why we use packages when managing software is because it lets you split a large range of functionality into several manageable chunks that you can swap out and upgrade anytime you want. So why use package management? Imagine that you're a software engineer working on a really large project and you have hundreds and hundreds of packages that you need to work with on your project, like they're all dependencies of your project. There's absolutely no way that you're going to be able to remember what every single package does and when they need to be updated or when you need to swap one out for a better performing one. So this is where package managers come in. It keeps track of all that stuff so that you really don't have to. So managers are a great way to basically install, uninstall, and upgrade any of these packages at any point in time. Next, I'm going to go over a couple examples of package managers that you may have heard of. The first one I want to go over is for Mac OS X. It's called Homebrew. And you execute a Homebrew command with the lines brew, install, and then whatever package you're installing. So Homebrew is a very easy way to upgrade packages, as in software or whatever, on your computer on Mac OS X. Some examples of these can be Git. Obviously, you guys have all used Git. I'm sure you enjoy it very much. GIMP is it's a photo editor, very similar to Photoshop or Paint. And libpng and GTK+, You guys may not have heard of this, but in the future, you'll be taking CS225 and CS233, and these are libraries that you can use to run your code natively on your computer. So the standard description of these courses tell you that you should run your code on an AWS machine, but you can use Brew to install the packages you need to run your code locally and save a lot of time. So you don't really have to make the trek to Siebel, especially in the winter, to get down to the AWS machines and do your work. The next one I want to talk about is apt-get, or pacman, and these are package managers for Linux distributions. And these are a lot more essential to installing software on a Linux machine than they are for a Mac machine, because obviously you can just jump to some website and download a Mac app really easily, or use the App Store. The App Store is actually a very, very wrapped package manager, if you think about it. But also interestingly, these package managers can also be used to upgrade your actual operating system itself. So that's something to think about. Unfortunately, Windows doesn't really have a strong package manager for development purposes, so I'm not going to be covering them. Next up, I want to cover some language-specific package managers that you will probably use if you ever work on large-scale projects. So the first one I want to cover is the Node package manager. It's called npm. And you run it just npm install and then the package you want. So you can install a lot of Node.js programs this way, such as like Grunt, it's a build system, Bower, another package manager. You can install things like Express, Less. The next one I want to cover is pip, which is the Python package index. It lets you install Python programs or Python scripts to run on your computer. And some of these may include like Flask or Django. Obviously these, you guys have heard of before, these are backend service. These are backends written in Python that you can use for your web projects. Additionally, you can install little frameworks like StatsD. StatsD is a statistics pipeline. It's like a little analytics tool that you can pipe data through to get some kind of output. It was actually developed at Etsy, if you guys heard of that. And the last one I want to cover is Gem. So Gem is the package manager for Ruby, and it pulls packages from rubygems.org. It's a repository for Ruby programs. And you can install Ruby programs like Sass. It's like a styling sheet. You can install Capistrano, which is another distributed build system. I actually used Capistrano this summer for my internship. You can install something like Rails if you want to do Ruby on Rails work. You can install Sinatra, which is like a full stack framework for Ruby. So you can even install text editors using these package managers. It's like Eclipse, for example. You guys use Eclipse in 125, don't you?
Hey, so we're here, right? So I do have a problem with, who uses an IDE here? There's no sin. Like, I would use one too. But no, guys, don't use IDEs, just for the sake of this lecture. I'm forcing you guys not to use IDEs. Now, I think to give some weight to my words, I'll need to demonstrate what it means. So hey guys, welcome to my world. This is the evil world called Emacs. Just kidding, it's gone now. My world disappeared, guys. We gotta leave. Oh, just kidding, guys. My world's back, so we're good. So here, I'm going to show you guys something pretty unique, or what I think is very good. This is kind of what happens when you get very comfortable with your configuration. So to your left, I have basically a large list of schemas. So what it comes down to, where it comes from, is I got this from the Communities in Crime dataset. This was a project that I worked on to basically predict, given a lot of factors, as you can see here, it's a lot of factors, what the basically how likely it is to have a crime in that region. Now to do that though, I wanted to generate a schema. So as you can hear, to your left, I do have a lot of, basically just copied and pasted from the website itself. And to your right, I have basically a Python header. So I want to go from what I have to the left to what I have on the right. Now, if you're just thinking like basic text editing terms, we'll have to do 128 edits, which is not fun at all. And we're programmers, why not basically automate it? Now, when I mean automate, I don't mean something cool like, I can't do anything cool, like, just click a button and it works for me. But I can do something, make my work a lot less. So what I'm going to do is I'm going to do what's called visual line. Essentially, I'm just selecting all the text. It's just a fancy way to say it. I'm going to use what's called multiple cursors. So what that allows me to do is edit all the lines at the same time. So there we go. Let's go to the back. Delete the last character. Now let's go back. Word. Delete the next character. Now all we need to do is delete all the apps. Now we just add a quote. We move the quote to the right. And just wait a bit. It takes a lot to process. Then we just append a comma. And there you go, guys. We just did all that work in less than like a minute when you could have done it all by hand. So this is what we mean by when we want you to work on your text, when we want you to work on your workflow. We want you to go from basically doing less of the boring stuff and doing more of the fun stuff, which is programming in our case. So no, IDEs don't suck. What I do want you to do though is that I want you to explore other options out there. I do understand that IDEs come with plugins, which you can actually do stuff like this. That's fine too, but I'm trying to introduce you to a new world where you can easily do stuff that I just did. So the first one, as you can see, I didn't mention Atom at all. Now I'm pretty sure a lot of you guys use Atom, or have used Atom before. This is my opinion on Atom, so why the heck would you use it? Like, why would you use it? The reason for that is because it does have flaws. Basically what it tries to do is it tries to be like Sublime Text, but Sublime Text is already out, and I recommend Sublime just for the sake of the ease to use. So yeah, Atom is constrained by limitations of Node.js, but it is free, and it's very actively developed, and there's a lot of plugins. So yeah, I'm going to talk about the more superior one, which is Sublime Text. Yeah, some people are like, what, right? Yeah, Sublime Text has this weakness. Some people don't like Sublime because it's not Vim or Emacs. That doesn't even make sense, right? You'll see why though. So Sublime Text, see, it doesn't have keybinds to be able to parse through your document quickly. As you saw on the my Emacs configuration, I was jumping around text everywhere. That's because I'm very used to doing it, but you probably wouldn't know what it feels like until you actually tried it. But you know, I mean, Sublime Text, right? It's beautiful, just like Mac OS X. It has a lot of, you can download a lot of plugins by default. And it's awesome. So this is where we go into the black magic of programming, which is keybinds. What I mean by keybinds is essentially keystrokes that will allow you to do something. For example, you see that ugly piece of text next to Vim, G5JDD escape :W. What that does is it basically goes to the beginning of the document, scrolls 5 down, deletes that line, and it saves the file. So you guys wouldn't know this unless you use Vim. So hence, it has a very difficult learning curve. It's kind of difficult to get used to, especially if you've been using your mouse your entire life, basically, which was me. And it also comes with difficulty in installing plugins. For example, autocomplete on Vim, it's not fun to install, trust me. But it does support like other plugins pretty well. For example, theming Vim is real easy. All you need is basically one line of code and downloading the theme file itself from somewhere. And of course, it has keybinds, and it's everywhere. AWS, pretty much every Linux distro does it by default. We're not talking about Windows. No. Now, if you thought Vim's keybinds were like ridiculous, no, this is what I use. This is like, you have to be a maniac to use this. And the title basically explains, it's a running joke in the programming community, that Emacs stands for Escape, Meta, Alt, Control, and Shift. This is because to navigate through text, you're going to be pressing a lot of keys that you may have never even heard of in your life. And that it's kind of ridiculous. So that's why it has a harsh learning curve. If you're a beginner, which some of you are obviously, and hell, that even if you're not a beginner, and you're not used to using text editors, I don't recommend using Emacs because it's just so hard to learn. It's also very difficult to make a decent configuration. As you can see there, that's actually Emacs by default. It looks kind of not that great. And the Emacs that I use is all heavily configured. But it does, the good part is that it has keybinds. And the fact that it's so flexible, there's basically a dedicated language to configure Emacs in. It has a lot of potential. And that is something that you guys should understand. So guys, I think, to be able to be really good at using text editors, you guys need to version control your configuration. And what does that mean?
So that means you can store your configurations in a version control system like Git, put it up on GitHub. And additionally, I do want to say that for Vim and Emacs, if you guys come to Hackerspace, we will have worksheets showing some example keybinds for these text editors that you could possibly go over and practice in Hackerspace with us. So what do I mean by version control? I mean using a version control system. So why would you use one? The main point is collaboration. So a version control system allows several people to work on the same project at the same time. So like for example, let's say you're in your groups and you guys are working on your project and one person yells, I'm working on the compare method. That's not a really feasible or scalable way to manage your project code to make sure two people aren't wasting their output and their workflow. So version control systems allows these people to work on the same code base, even like the same part of the same code base in real time. Another point that's very beneficial about version control systems is that you can store these versions. Obviously, it's in the name. So by definition, version control systems will store differentials on each of the previous commits to it, so that at any point in time, you can go back and look at any of these versions and use any of them. So this is very beneficial. For example, let's say you're building a website and you guys have 4 different designs from your designer and you want to render them all and see how they look. So you can create 4 different branches in your version control system for each of these designs and be able to switch between any of them really, really easily to see your website. The last thing I want to cover is kind of inherent from story versions, which is backups. So let's say your friend, being the idiot that he is, kind of commits like some really bad code or deletes a file from your system. A version control system will allow you to easily recover that file and no harm done. You can just restore back to the previous version of the code base. So next up, I'm going to cover a couple of examples of version control systems. So obviously you guys use Git for your homework. You can put your code up on GitHub. So GitHub is the first one I want to cover. It's like basically the largest host of code out there. So it basically has the largest code base that's available for the public to see, and it's done using its version control software is Git. So a benefit to using GitHub is if you want to make your code very public and get your code out there for other people to work on, or if you want to work on a very large open source project, chances are you want to use GitHub. Other one I want to cover is Bitbucket, which also uses Git. So Bitbucket, for example, might be beneficial for you to use if you want to store private repositories. So let's say you really want your code to be private, like you're working on a homework assignment and you don't want other people cheating off you. You can use Bitbucket and use their private repositories to store your code. They give them away for free. The third one I want to cover is called Mercurial. So Mercurial is more of an industry standard repository system. It's fault tolerant and scalable because it's distributed, and it's more so meant for thousands of people working on the same code base. It's used a lot in companies or just a regular student side project. And the fourth one and the last one that you guys probably use is Subversion. So Subversion is used by the university. It's obviously the simplest version control system to use. And the university uses it because, one, they can host their Subversion repositories and servers locally instead of in some cloud-based storage system. And it's also very, very simple for students to pick up and use. There are less commands to actually use it. So those are a couple examples of version control systems. I hope you guys maybe use one already or will use one for your code. And basically what you want to pull from this lecture is set up your workflow. You want to incorporate as many aspects of efficiency as you can into your dev environment so that you are better able to code and you have better time coding.
And if you need help setting up your workflow, you can contact me. I'm Shotaro. I'm the first one on the list right there. And Aravind is the second one. We're more than willing to help. Just shoot us an email and come to the next Hackerspace.
All right. And next up, we're going to have Peter and Eric talk about APIs.
Yeah, Eric.